Hello and welcome to another ARM software developer breakdown. My name is Robert Wolf, and in this video, we are once again joined by Paul Howard, Principal System Solution Architect from ARM. If you missed any of the previous parts to this series, cruise on down to the description and find the part that you're on. In our last video, Paul showcased key provisioning and RSA encryption end-to-end using Embed. And in this video, we'll be adding an HSM, otherwise known as a hardware security module, to PARSEC. So Paul, I think we're ready for your walkthrough. Take it away.
Thanks, Robert. So yes, the topic for this video is hardware security, and this is where we'll see the real power of PARSEC. If we want PARSEC to protect our private keys, then really we want to provision them and keep them protected right inside of the hardware. Now here on a Raspberry Pi, we don't have any hardware security built into the board itself. The best we can do is store our private keys on the SD card storage, which is not very secure. Now we can do better by adding some hardware as a peripheral, and there are a few different ways that we can do that. We could seat something like a trusted platform module, a TPM, onto the GPIO pins of the Pi, but in this case I'm going to use a portable hardware security module, an HSM, which I'm just going to plug into the Pi on the USB port. So here we are actually adding the HSM to the Raspberry Pi 4. I'm using a Nitrokey HSM in this case. Other products are available. Installation's real easy. We don't need to open up casing. We're just going to plug this thing right onto the USB port like this. Now PARSEC can use any HSM with a PKCS11 interface, but for this one to work, we first need to install a PKCS11 library for this device. So back here on the Pi screen, we're going to get that installed real quick now. Nitrokey uses a library from OpenSC, and we can install this nice and easily on the Pi just with an apt install like this. And this should be fairly quick. This one's a fairly small package. Okay, so once that's done, let's take a quick look about how we tell PARSEC to use the Nitrokey. Now remember that we built PARSEC from source code earlier on the Raspberry Pi. Now in order to talk to the hardware, PARSEC uses these back-end modules called providers, and providers can be either included or excluded using feature toggles, which are supported in the Rust and Cargo build system. Now you might remember that when we used Cargo to build the PARSEC service earlier on, we supplied two feature flags to build two different providers into the service. We built the Embed crypto provider, which just stores keys on the file system, but we also built this other provider, the PKCS11 provider, which we haven't used yet, but this is the one that we are going to use to access the HSM. Now, although both providers are compiled into the service, they are not both active. It's actually a runtime configuration file, this config.toml file, which tells PARSEC which providers to activate. Now, when we started up PARSEC, we didn't apply any configuration. We just used what we got out of the box from GitHub. Now, that default configuration of PARSEC only selects for the Embed crypto provider. So our PKCS11 provider is not active by default. The Embed provider stores its keys on the Linux file system. Now on the Pi, that's backed by the micro SD card that we have installed. So that's where our key material is being stored. But if we go and edit that config file and apply some runtime configuration, we can tell PARSEC to use a different provider. If we activate the PKCS11 provider, then this will swap everything over, and PARSEC will go and use the HSM to store its keys. And it means that private keys are now going to be provisioned directly into that secure hardware module. They'll never be made available to software outside of the secure boundary. And this is the real beauty of the way that we use PARSEC. It's not going to change. We only need to reconfigure the service, which would normally be done as an admin step at deployment time. The way we talk to PARSEC doesn't change. The clients of the PARSEC service will not notice any difference between these configurations. So any code in the client remains completely portable across these back-end solutions. Now, the great news is that in the next video, we're going to turn this theory into practice. We'll be heading back to the Pi and doing one more demo with real hardware security protection. So with that, Robert, it's back to you.
Thanks, Paul. And that pretty much wraps up this part of the series. Stay tuned for the next video when Paul outlines the RSA workflow with PARSEC using hardware encryption. You definitely won't want to miss this one. As a reminder, don't forget to like this video, follow our channel, and we'll see you in the next ARM Software Developer Breakdown.